Hey everyone, welcome back. So today I want to talk about something that honestly confused me for a long time. What even is the difference between a load balancer and service mesh? Like aren't they both just managing traffic? Well not. And by the end of this video, I promise it will all make sense. Let's jump in. Okay, so here's the plan for today. We will start simple. What is a load balancer? How does it work? Then we will hit a problem. Why is a load balancer actually not enough anymore? And then we will see how a service mesh fix it. And finally, I will show you Kmesh, which takes this whole thing next level. Sound good? Let's go. Alright, so imagine you walk into a restaurant on a really busy Friday night. Like 100 people show up at the same time. Now, if there's only one waiter, that poor guy is completely overwhelmed, right? Nobody gets their food on a time. Everyone's frustrated. So what does the manager do? He says, okay, table 1 to 10, you go to waiter A. Then table 11 to 20, waiter B, and so on. He is distributing the load equally. That managers, that your load balancer, the waiter. Those are your servers. Simple as that. So, how does it actually work in a real app? Let's walk through in a step by step. You open app on your phone. That's step 1. A request is made, that request doesn't go directly to a server. It hits the load balancer first. The load balancer then look at all the servers and says, okay, which one is free right now? Found one. Great. Sends the request there. And you get your response back. The whole thing happens in milliseconds. So, tools like Nginx, AWS Load Balancer, HA Proxy, these all are doing exactly this behind the scene. Okay, so load balancers sound great, right? But here's the thing, and this is where it gets interesting. A load balancer only sits at the entrance of your app. It's like a bouncer of the door. It can control who comes in, but once you are inside, it has no idea what's happening. And modern apps are not simple anymore. Inside your app, you have hundreds of services constantly talking to each other. Payment service calling, order service calling, inventory service, and inventory service calling notification. All of this happening internally. And the load balancer, it can't see any of it. It can't secure it. It can't retrieve something fails. Can't even tell you which service is being slow. So we have a problem. To really understand why this matters, let's quickly talk about microservices. So back in the day, apps were built one big block. We call it a monolith. Everything, login, payment, orders, all in one place. Sounds simple. But the problem is, if one thing breaks, the whole app goes down. So engineers came up with a better idea. Break it into small independent services. Each service does one thing. Login service just handle login. Payment service just handle payments. They are all separate. They can be updated independently, much better. But now all the services need to talk each other over the network. And with hundreds of services, that internal communication became a massive challenge. Who secures it? Who monitors it? Who handles the failure? That's exactly the gap mesh file. So, service mesh, think of it like a smart individual layer that wraps around all your services and manage how they talk to each other. You don't have to write any extra code for this. It just handles it. What does it handle? Four things: security, observability, reliability, control. So we walking through what does security do? Security. Every conversation between services is encrypted automatically. Observability. Observability. You can actually see in real time what talking to what, how fast, any error. Reliability. If service fails, it automatically retries. You don't have to build that yourself. And control. You can set rules like, hey, only the payment service is allowed to talk to the database. Nobody else. Pretty powerful? Right. Okay, let me show you exactly how this works. Without a service mesh, service A just directly calls service B. Raw connection, no interruption, no monitoring, nothing. If it fails, it fails. Now with a service mesh, each service gets a small helper stretched to it. We call it a sidecar proxy. So now, when service A talks to service B, it talks to its own proxy first. That proxy handles all the heavy lifting, interrupts the traffic, retries if it fails, records the metrics, checks if the service even has permission to take that call. Service B's proxy receives it, decrypts it, pass it in. The services themselves don't even know this is happening. It's all automatic. So let's put side by side real quick. Load balancer works at the entry point, manages traffic coming from outside, basic security, limited visibility, service mesh works inside your app, manages traffic between your own services, strong interruption between MPLS, full observability. The way I like to remember it, load balancer is the door of your app and service mesh is nervous system. The door controls who enters. The nervous system controls everything happening inside. So you might be thinking, okay, this sounds cool, but do real company actually use this? Absolutely. Netflix, they have thousands of microservices. If one service goes down and they don't catch it instantly, millions of users are affected. They need a service mesh. Uber, millions of requests every single second, so they cannot afford even one services to be slow or unresponsive. Next is Airbnb. They are handling sensitive user data, payment info, personal detail, every detail services, communication need to be secure. And this is the pattern. The bigger your app gets, the more microservices you have, the more you realize a load balancer alone is just not enough. Okay, so now let's talk about KMS. And this is where it gets really cool. Traditional services meshes are great, but they have one annoying problem. They put a proxy container in every pod, which is not good. So if there is 100 pods, there's 100 extra container just sitting there. That's extra memory, extra CPU, extra delay on every single request. KMS says, what if we didn't need those proxies at all? Instant KMS uses something called eBPF, which runs directly inside the Linux kernel. No extra container, no extra overhead. You get all the same features, security, observability, reliability, but way faster and much lighter. That's why it's called next generation. So, alright, let's do a quick recap. Load balancer manages all traffic coming from outside your app. Great for distributing requests across servers. As apps become microservices, load balancer alone wasn't enough anymore. Service mesh steps in to manage traffic inside your app, add security, monitoring, reliability automatically, and KMS takes it further by removing the proxy overhead using ePPF, making it faster and lighter than traditional services meshes. And that's it for today. Honestly, I hope this cleared up the confusion between load balancer and service meshes. Because when it clicks, it really changes how you think about building a scalable app. If you found this helpful, give it a like and subscribe to the KMS channel for more tutorial like this. Thank you for watching and I will see you in the next one.